Hey everybody, it's Mr. Zabo. Today we are going to talk about sections 3.3 and 3.4. These sections can be a little bit heavy. There's a lot of material in here. We're just going to kind of brush the surface of it on the video and then we'll get into more depth as we get into class. But what we're going to cover is something called the principle of CP/CTC, which we'll define here shortly, using it in our proofs. We're going to talk about and recognize a property of circles that we all already know, and then we're going to take our understanding of certain concurrencies and auxiliary lines within triangles to go beyond this CP/CTC. So without further ado, let's take a look at a proof that's already done, and it's a complete proof. And it says that because segment CE is perpendicular to segment BD, which was given, then I have two right angles because perpendicular tells us right angles, and they're congruent because right angles are congruent. E is a midpoint of segment BD, so I have two congruent segments because midpoint implies two congruent segments. I remember the reflexive property, and now by side angle side congruence, my triangles are congruent. So if I mark in my diagram what I know are congruent, I knew that segment or that angle CEB and angle CED were right angles, therefore congruent. We knew that segment BE was congruent to segment ED because E was a midpoint. And then we had the reflexive property here. Those are the three pieces of information that allowed us to conclude that these two triangles were congruent. However, now that they are congruent triangles, we can actually take a step back and recall what the definition of congruence means. Because my triangles are congruent, it means that I have 6 congruent parts. Well, 3 of them have been named in our proof already. That means there's 3 more that are now we can conclude are congruent. We can't assume it, we can conclude it because our triangles are congruent. And those are, well, segment BC must be congruent to segment DC. Okay. And then my other angles. Angle B must be congruent to angle D. That's got to be a congruent statement that's true. And you can see that from your diagram. Segment B, or from your congruent statement, is congruent to segment D. And then also segment or angle BCE is congruent to angle DCE. Now we cannot at this point just say angle C is congruent to angle C, angle E is congruent to angle E, and angle B is congruent to angle D, just from the statement like we would have without the diagram. With the diagram, it's important that we name them accurately. This concept here, once we know and have first proven the triangles are congruent, is something that we can abbreviate in our reasons as CP/CTC. But what it really stands for is that corresponding parts of congruent triangles are congruent. That has the makings of an excellent quiz question. What does CP/CTC stand for? And asking you to write out that implication. All right, so let's see, how do we use this in proofs? Well, the main thing that's going to be different is going to be right here. Our proof statement is no longer going to be that triangles are congruent. This case, it's segments, but I must prove triangles congruent first. Then I can use CP/CTC to state this. So I've got this already started and kind of worked out. I've got my two givens, and I can start labeling my diagram that angle MNS is congruent to angle TSN. I have the given that segment NW is congruent to segment SW. That's the wrong segment, Mr. Zabo. This segment is congruent to this segment. And I have the statement that angle 3 is congruent to angle 4. Okay. So because my big angle This green one that I have marked in my diagram is congruent as a given statement, and angles 3 and 4 are congruent. These are my small angles. That is the subtraction property, allowing me to state that angle MNW is congruent to angle TSW. That was my subtraction property. So quick review of some properties here. Then I can state that angle 1 is congruent to angle 2. At this point, I am allowing you to ignore the fact that I didn't state that they are vertical angles first. So for vertical angles from here on out, your proofs can now state angle 1 is congruent to angle 2 because vertical angles are congruent without first stating angle 1 and 2 are vertical angles, assumed from diagram. You can still state that if you'd like, but you are not required to anymore. You can go straight to the vertical angles being congruent statement. Now, as I look at my diagram, I now have triangles that are congruent, and it's going to be these two triangles here and here are going to be congruent because I have angle, side, angle congruence, but I have to state the triangle names. Okay, so in this case, I might call it triangle MWN. The first one doesn't matter. How I name the first triangle does not matter, but how I name the second triangle does. I started with angle M, that corresponds to angle T, so I have to start with angle T. Then I went to angle W, which is got angle 1, that corresponds to angle 2, which is also at W, so I must go to W, and then lastly I can say S. Now that my two triangles are congruent, and these segments, segment MN and segment TS, are corresponding parts of those triangles, those segments are now congruent because corresponding parts of congruent triangles are congruent. So that is how we will use the CP-CTC in proofs. Real quick, circles, all radii of a circle are congruent. So I know if this is a circle and that has a length of, say, 3, well, then this has a length of 3, and this has a length of 3, and this has a length of 3. All radii are always congruent within a circle. So now that we have talked about that theorem, we can now use that in proofs as well. And that leads us to our next proof. Here's how we use that theorem. You have to be given that it's a circle. So you can't assume it's a circle, but we've been given circle O. So I have to state that given statement. But now that I know it's a circle, I know that AO and EO are congruent. And my reason is radii imply congruent. Okay. I know they are radii of the circle that was already given. Okay. Then I have my two given midpoint segments. B is a midpoint, D is a midpoint. Here is where you do not need to state that segment AB is congruent to segment BO and that segment OD is congruent to segment DE, because now we have three really important statements. One big segment that's congruent, along with those two big segments being bisected. Congruent, bisect, bisect allows me to conclude that every single piece or every single divisor of that big segment is congruent. In this case, I can now conclude segment BO is congruent to segment DO through the division property. Since I'm trying to, if I take a step back, conclude that segment CB is congruent to segment FD, that's what I'm trying to conclude, I have to first prove, if I look at what parts of those triangles, that triangle BOC is congruent to triangle, well, I started with B, that's going to go from D, D is going to go to O, and O is going to go to F. If I can show this first, I can then show this through CPCTC. So I'm trying to get those triangles. That's why I wanted segment BO congruent to segment OD. And next, I have stated that my vertical angles are congruent, and I can conclude in number 7 that CO is congruent to OF as well for the same reason as number 2. Those are radii of a circle. Now, my triangles are now going to be congruent. Notice I named it different in the pink up here than I did down here. That was on purpose. Okay. In the pink, I said triangle BOC is congruent to triangle DOF. Down here, I can't call it triangle DOF. Because I started with angle O, I have to start with angle O in my other triangle. I went from O to B, so I have to go from O to D, and then I can go from D to F. And if I look in my triangle at what I have marked, I have segment CO is congruent to segment OF. I have my vertical angles, and I have that segment BO is congruent to segment OD. That is side angle side congruence. Now that my triangles are congruent, I can make my last statement, my conclusion that segment CB is congruent to segment FD because corresponding parts of congruent triangles are congruent. Okay, at this point, instead of starting and trying to rush through the rest of this, I'm going to stop this video and post a second video for this section. It's not going to be as long as this one, so please go ahead and make sure you watch the second video that's going to cover mostly section 3.4.